Hi there. So thanks for joining. I'm Mike Smith. I'm a smart manufacturing consultant for ATS in the UK. I've been working with ATS for 9 years now, working on various SCADA, MES, and manufacturing operations management projects. Usually going into customer sites and helping them to improve their facilities and operations to move towards their digital strategy goals. And today we're going to be looking at OEE and how we raise the bar of plant performance. So thanks for joining again, but before we get started, if you'd like to ask a question at any point during the webinar, could you enter it in the webinar control panel? So you should find in your kind of control bar, there'll be a bit to type a question in. And then I'll answer your questions at the end of the webinar. There's also a white paper on that webinar control panel that you should be able to download and get some more information from. All right, I will get started. So today, organizations on aggressive growth paths are looking for sustainable operations excellence. And to deliver this, production managers are expected to raise the bar and make the most out of available resources. And I guess that's especially prevalent at this time where there's lots of cutbacks and issues in manufacturing. We really need to make the most out of what we've got on our shop floor already. So the value of information is inversely proportional to the time required to reach the intended audience and directly proportional to the number of people receiving it. So that means that we need to get the paper to the right people or the information to the right people at the right time in order for it to be valuable. So in practice, when you're using paper to capture downtime, the information about stoppages only becomes visible at the end of the shift or the next day when it's already too late to react. So it's not really useful or valuable anymore. If the machine operator is aware of a stoppage, only the operator can react. But if the information is shared with maintenance, supervisors, managers, or planners, then that information becomes more valuable as more and more people can react to resolve the issue. So today we're going to look through the what, how, and why of OEE. So most of you will have come across OEE and probably know what it is, but we're going to run through this just so that we know that we're all talking about the same thing. We're all on the same page. Some of you will know how to implement OEE and may even have already implemented OEE system. We're going to run through some tips and guidance for a truly value-adding OEE capture system. And then finally, often it's something that we just do, or we know that we should do, or everyone else is doing, but we don't necessarily know why we should do OEE. So we're going to look into this as well. So let's start off by looking at what OEE is now. So often we see OEE as a single number. So something like 65%, or if your production process is really good, then perhaps it would be around 85, 90%. But there's more to OEE than just this headline number. So OEE is a combined metric that shows the effectiveness of a machine. So it's overall equipment effectiveness. So you can use it on a machine, a process area, a production line, a facility, site, or enterprise. So the calculation that we prefer is availability times performance times quality is OEE. So it shows us how well something's functioning compared to its optimal and provides valuable insight into the true capabilities of the production process to meet the demands that we're placing upon it. So here we have, so we've got A, P, and Q. So we're going to look at the lower level metrics that make up OEE. So each of these are captured as a percentage and can give really meaningful information into the production environment themselves. So we have availability, so based on planned and unplanned stops. 100% would be always running during planned production. We've got performance, so this is a slow cycles and micro stops affect this. So 100% score means that the process is running as fast as possible. And then we've got quality, so produced product, defects and good parts determine the quality. 100% quality means that all of the parts are defect free. So we're just going to look into these metrics into more detail now. So we've got availability. So the relevant key metrics associated to availability are MTBF. So we've got mean time between failure. So this is the time duration between a component failure of the system. So the average time between failures of the system. And then we've got MMTR, so mean time to repair, which is the time it takes to resolve that failure that we've already spoken about. So the associated losses with availability are breakdowns and product changeover. So availability takes into account all the events that stop planned production long enough where it makes sense to track a reason for it being down. So typically this is around like the several minutes mark rather than the micro stops and small blips in production. So this means that any scheduled maintenance will not affect your availability or its associated OEE score. So if a piece of equipment is only meant to be running for an hour a day and it runs for an hour a day, it will be fully available. Product changeover does contribute to your OEE score. So production line area that has to deal with a high product variety and associated product changeovers will have its availability metric impacted. So there may be nothing that can be done about this. So it's key that you understand what's behind the data before comparing metrics across sites. So you could end up with a production area with a low availability that just has to deal with lots of different part variation, and then another production area that's continually processing the same part doesn't have to deal with that issue at all. So in that sense, it's good to know what's behind before you start comparing those metrics. So availability is calculated as the ratio of runtime to planned production time. So availability is runtime divided by planned production time. And runtime is simply the planned production time less the stop time, where the stop time is defined as all the time when the manufacturing process was intended to be running, but was not due to unplanned stops. So breakdowns, planned stops. So runtime is planned production time minus stop time. So if you're suffering from machine breakdowns bringing down your availability metric, then it would be worth looking at your maintenance schedules, making the transition from reactive to planned and then to predictive maintenance. So by having a poor availability metric, that can kind of help you pinpoint various issues that could be affecting that or bringing that particular metric down. And it will give you something to target as you go forward. So the next one is performance. So performance takes into account anything that causes the manufacturing process to run at less than the maximum possible speed when it is running. So this includes both slow cycles and small stops. So the associated losses with performance are running at reduced speed and minor stops. So performance is the ratio of net runtime to runtime. So it's calculated as performance is ideal cycle times times total count divided by the runtime. So basically it's how optimum is your piece of equipment running against how it can run. So ideal cycle time is the fastest cycle time that your process can achieve in optimal circumstances. So when it's multiplied by the total count, the result is net runtime, so the fastest possible time. The rate's the reciprocal of performance can also be calculated as performance. It's total count divided by runtime all over the ideal run rate. So this ideal cycle time may vary for different parts that are going through your system. So if you have a lot of part variation, then it's very important that this cycle time is tied to the parts that are running through that piece of equipment at that particular time to get meaningful value out of this. Don't be tempted to use reduced cycle times. So a lot of people are tempted to use budget cycle times or standard speeds for OEE, or maybe they'll use the cycle time that they happen to be achieving at the moment. If they're slower than the optimum speed that the piece of equipment or the process or area or person can accomplish, then you're just robbing yourself really. Your OEE will look good, but it won't be true OEE, and you'll be fooling yourself and hiding potential production gains that could be made. So if you get the process closer to actual optimum cycle time for the process, your OEE should improve. Performance should never be greater than 100%. And it probably won't be greater than 90%. I mean, if it is, it usually indicates that the ideal cycle time is set incorrectly. So yeah, you're cheating yourself. And then quality. So quality takes into account manufactured parts that don't meet quality standards, so including parts that need rework. OEE quality is similar to first pass yield in that it defines good parts as parts that are successfully passed through the manufacturing process the first time without needing any rework. So associated losses to quality are rejects that are created as part of the startup or initial run after product changeover. So that'll be while the process is adjusting to the change of a different part running through it. These can often be reduced by investigating and improving machine setup or the sequencing of different part types running through the process. So if you have a lot of parts changeover, if you can then sequence together similar parts, the changeover could be quicker and cause less losses in that respect. Running defects are the other loss associated with quality. And we've got quality is good count divided by total count. So this is the same as taking the ratio of fully productive time, only good parts manufactured as fast as possible with no stop time, to net runtime. So all parts manufactured as possible, as fast as possible with no stop time. As with performance, unfortunately, if your quality metric is too high, then perhaps this is too good to be true and you're again fooling yourself. Unless you've already been through the process of going through your production process and really improving your quality to get where you are, it's probably worth investigating if your quality and perhaps investing in a quality system. If your quality metric is too high, maybe you want to look into that. And again, also if it's too low, you should start looking into how to bring that up. So we've got tip number one. So what can be measured can be improved. So once you've got your measurements and understand what's behind them, you have a baseline for your facility and you can start looking at the data and you can start creating a strategy on what you're going to target for improvement. So the measurement itself is not the end result. If you measure OEE and do nothing about it, then you've just created an expensive dashboard. You've captured a lot of data, which you then have to store somewhere. But the real value is in collecting the right data and then acting upon it in a meaningful and strategic manner. So once you've measured it, you then need to start improving it. So we've looked at what OEE is, and now we're going to look at how we should implement an OEE system. So be clear. So clarity is vitally important if you want your OEE metrics to be meaningful and usable. So you need to have your data and you need to be clear about what that data represents. So you need to set your downtime event start and end definitions. So understand when a downtime event is starting and what that event is that ends the downtime. So commonly downtime will start with a machine fault and it will end with a machine either being returned back to an operator or back to production. But you just need to set those events and be consistent about them against different places where you could be measuring your OEE. Stick to your OEE calculation, so create your metrics in the same way across your facility. So whilst comparison between different processes can be difficult due to the different restraints and requirements of processes, like I was saying before about areas of high part changeover, as long as you know what's going on behind the scenes, then you can compare these metrics as long as you measure them in the same way. So you just need to make sure you're being consistent and you can make allowances for those different areas based on the same metric. Define your machine states and prioritize them for downtime reasons. So a machine states every possible condition that your machine or process can be in. For example, faulted, running, blocked. So these states can be customized for your particular process and can go as detailed as you like, but should be given priorities. So for instance, if a machine is faulted and starved, the faulted state should be given the higher priority and recorded against the machine as that's the reason that the issue is there. So you could have, if you had multiple events triggered that could cause a downtime, you need to be sure you're capturing the one that has the highest priority and would actually stop the machine. If you're prioritizing your production scheduling, then perhaps you would prioritize starvation against a machine fault. It depends kind of what aspect you're trying to improve as to how these priorities are, possibly. So you need to define your produced parts with their standard production times. In terms of performance, the throughput of a machine will vary, or it could vary greatly depending on what part it is producing. So you need to have that clear and defined. And that's particularly useful when we talk further on about the integration of these things. So if you understand how your production can perform, if your process takes longer to produce certain parts, then you need to get this defined against the optimum speed for the process and the part. And then the other thing about being clear is to make this information available to people. So by making the information available, it means that anyone can start to notice areas where they can improve and make adjustments on the fly. This obviously needs to be monitored and controlled to a certain extent, so that any adjustments that are made without the awareness of any initiatives being carried out by your continuous improvement teams. So if you have an initiative focusing on a particular area, and you have some operators on the shop floor doing their best to improve something because they see the issues, then yeah, maybe that's something to be aware of. You don't want to end up fighting against the same issues, but making this information visible and available to people can often bring real value. Be visual. So collecting data you can't see is not going to bring any value, but visualize your results. So it's quite common in the world of OEE to see a 30% improvement just by displaying the numbers. If you start putting the OEE values on the shop floor, it's common that operators will notice and they will do things to improve it, if only because it's driving a competitive spirit on the shop floor and they're trying to beat their mates on the other line or something. So by showing this information, making it visible, not just at the shop floor, but all throughout your facilities, people can start to see correlations between incidents, between parts, maintenance. And a lot of the time, this is valuable human information that can be captured, especially if they put an easy and accessible reporting tool in there. By creating virtual dashboards and reports, you're able to visualize how your facility is performing and also to respond to any breakdowns or shop floor issues. So the more visualization you put in, the more you can see, the more you can understand what's going on, and the more you can act on it. So this is, so tip number 2, shout about it. So in one example, we have the findings were displayed on the shop floor in real time and shared with people. So everyone saw the stats on the shop floor. The machine operator noticed that the stoppage time of the machine was extremely high when making a certain product when compared to the others. So just by visualizing this information and sharing it with people, there's valuable insights that can be attained with very little effort. With people, there's a lot, visualization is kind of the integration to people. So it's very important to capture that. Be integrated. So I've got on the right there the different layers of the ISO 95 integration pyramid. So we've got level 0 production processes, level 1 sensors and actuators, going up to automated process control, manufacturing operations management, and then up at the top to the business planning and logistics. So the data being captured can help you to target improvements, but it can also give you a realistic understanding of your shop floor. So by integrating this data through the levels of integration, the systems and logic will be able to perform better. So just in the same way as we're visualizing it to people on the shop floor or in offices through dashboards and virtualization, by integrating it, we're integrating it into these systems, and then they can have information that they can act upon as well. So integration has been a key trend in industry for years, and this is only increasing with Industry 4 and digital connected factories. In the same way that information must be visualized and shared with people, this is true for systems, and perhaps more so. By integrating your OEE and associated data in real time, your business decisions can be informed and achievable. If your business planning knows what's happening on the shop floor, you can have accurate, realistic planning. If your scheduling system understands what's happening on the shop floor, it can adapt, improve your schedule. Basically, you can improve your OEE, your quality, your performance, and your availability. So we've looked at what OEE is, how it should be implemented, and next we're going to look at why we should implement an OEE system. So OEE is a valuable metric for the monitoring of your production environment, giving an indication of how well your plant's performing on a high level, and then also at the lower level, what aspect of the plant's causing concern when you drill down into the properties that make up the OEE metric. So this understanding helps you to use the assets that you have to the best of their potential. You can see when an asset's underperforming. You can see when those expensive machines, pieces of equipment on your shop floor, you're not getting the value that you thought you would from them. So you can understand where to target valuable investments, but also where to improve production processes where it will make a meaningful difference. You can identify bottlenecks on your shop floor, maintenance issues, things like that. So the real reason you want to know your OEE is so that you can find out how to improve it, and also know that when you make a change that it is improving your OEE. So if you do something to relieve that bottleneck, has it made a difference? You can then start to grade those results. So our final tip, number 3, is effective root cause analysis. So zeroing in on the issues. So we must see the problem before we can find a solution. So we had an example where the production manager identified that short stops was a major cause of lost production on the machine. On investigation, the conveyor line person informed the production manager during a single pass of product A, the line stops. So he opened up the safety screen, realigned the product that catches the machine door. He closed the safety screen in the conveyor belt and it starts up again. For every 2 seconds of real production, that issue caused a stoppage of 4 seconds of downtime. And because of that, they identified an incorrect die design and placement, which caused the consistent stoppages, and the input was passed on to the die design and die setter team. So they realigned the way the product drops onto the conveyor belt and eliminated the short stops for that product. So by highlighting these things, you can zero in on the issues once you've identified them. So with the visualization of the analytics captured, data discrepancies can be identified between your understanding of production and the realities of the situation. So you can have lean initiatives and business improvement teams that will have clear metrics to target and areas that are in need of improvement to focus on. So as that data is real time, the improvement initiatives can migrate to an agile approach. So as they're carrying out their implementation, you can see results, you can respond as you go forward. So as I've already said, the value of OEE projects, it's not in the OEE metric, but to enable you to focus in on and understand where improvements can be made. So the issues that you will find will not be limited to your shop floor or production areas. The same could be said for things like quality systems. You don't implement a quality system because you want to know your quality, you implement it so that you can fix the issue and eventually do away with the quality system. The same is there for OEE. So I've put on here the Purdue reference model from the ISO 95 standard. So this covers the activities of manufacturing operations maintenance. So all of the ISO 95 activities that can be directly affected have been highlighted. So this area covers the production, manufacturing operations maintenance, and the interfaces between them in this diagram. So I've highlighted all the key areas, and you can see in the central area there's production control. But it doesn't stop there. So by capturing the OEE information and then sharing it with the interfaces throughout the different activities, you can then affect product cost accounting, product inventory control, quality assurance, maintenance management, material and energy control, production scheduling. So the OEE data can bring improvements across the 4 domains: production, maintenance, inventory, and quality. So I think often we see OEE as something for the shop floor. It wouldn't necessarily affect product cost accounting and material and energy control, but actually it affects all of these domains, especially when you start to integrate this data. And I think that's the key. Often we do OEE as in a bubble. We need to break that pattern, I think. So by integrating this data real time across the domains, your manufacturing operations management becomes enabled for agile production, and it can make decisions based on up-to-date information. So we've covered now at a high level the what, the how, and the why of OEE. So just before we move on, I just thought now would be a good time if we have any questions.
Mike, hello. Yes,
Okay.
we actually have one question from Trevor. It is regarding availability. Not sure if you can read it in your control panel. If not, I will read it loud.
I can't see anywhere.
In a chat or question. Okay, let me read it then. Regarding availability, a job will start and the job will finish. Then a changeover will occur. For example, change the mold over to another product. Is availability take into account for the changeover?
So,
is the question. Is availability take into account for the changeover?
So the availability will go down with the product changeover. So, so as I was saying, if you have an area with a high product changeover, then the more that changeover happens, because it's not planned maintenance or planned downtime, changeover is seen as part of production time. So the longer it takes for the so longer the changeover time takes, the more the OEE metric will drop down. So yes, it is taken into account.
Okay, thanks. And there is one more question. Does OEE work with all process types?
Yeah, it does. So yeah, I think OEE is often aligned with kind of high value discrete manufacturing processes, but it's about measuring productive time against planned production time. So yeah, it's just as relevant for high volume process industries and even kind of manual processes as well. Yep.
Thanks, Mike. So those are all questions so far.
Okay, great. I'll carry on for the next few slides then.
Okay.
So yeah, so how can ATS help? So based on everything we've talked about today and our experience within the manufacturing domain, we've created what you can see in the middle here, which is a templated object-based plant visualization and OEE project. So the intention that we had behind this was to create a project that can be easily and quickly customized to represent your specific facility or area of focus. So the intention is that this is a standard project that can be configured, so there's no requirement for customization or any time-consuming extension work. So at the moment, it's orientated in a portrait orientation, but it's split into three kind of basic sections. So at the top, we have the plant overview and the navigation area. The middle is showing the metrics, and then we've got a call for help assistance area at the bottom there. So at the top is this high level overview. So we've split it up here. So you've got the full plant and you've got 4 lines within the plant, 4 machines within each line. So this is configurable based on how your plant would be, the number of machines and number of lines, or however it would be set up. So the idea is that the shapes at the moment, so the rectangles, diamonds, circles and ovals, they're all green, but they change based on their various states. So we've got green for running, red is fault, grey's on a break, purple's blocked, orange is starved, and you can see a couple there with an A in them. So that's an alert that's been raised by the operator. So this is a high-level overview that gives visibility of the key metrics of the plant along the top. So they would probably be your very high-level site metrics. We've got things here like revenue generated and a number of reject items, equipment efficiency, and goods produced. So these can all be configured in the background to look at different metrics. Also, the navigation is done from this screen. So if you click on the L1, 2, 3, or 4, it will select a line. If you click on the top level, it will select the plant. And if you click on an individual machine, it will drill down to the machine area. So we've got these contextualized metrics as the middle section of those three screens. So we've got KPIs, so key KPIs that have been identified and trended over the last shifts period. So depending on your machines, these would be different things. So you might have things like spindle vibration, oil pressure, current, things like that. We've also got so the OEE side of things. So we've got utilization, so line, so each machine's utilization. If it's on a plant level, it would be each line's utilization, and then if we're at a machine level, it would be the productive time of that machine. Some of these figures on these examples are quite optimal, but yeah, in reality, they wouldn't be that high. So we've got throughput as well. So we've got these bar charts along the bottom, numbered 1 to 9. So that's kind of the last, the 8 previous hours and the current hour of throughput of that particular machine, line, or plant, depending on the level that we navigate to. And we've got the OEE radar charts and boxes. So it's just, we find that the radar chart's a really good way to kind of visualize OEE. So at the center, you've got the OEE metric, and you can see then the quality, availability, and performance. And at a glance, you can see what's pulling your OEE down at that particular level. And then we've got this call for help section at the bottom. So this central overview gives, at a quick glance, a view of where your shop floor problems are and what's going on to resolve them. So this screen is also contextualized based on the navigation section, so that it changes between plant overview, line overview, and machine details. So this allows you to drill down into the issues on the shop floor and see what's bringing down your OEE metrics. So you can see on this incidents in the middle. So line 1 has a high number of incidents in this particular shift, and that's the one that's causing the issues. And then we've got the call types categorized in the pie chart on the right. So at a glance, you can really see, depending on the level that you're selecting, what's causing issues with that machine, line, or in your higher plant. So the intention behind this was that you can place this screen in the appropriate offices or of various departments. So if you had a maintenance department, you had a tool setting department, wherever these incidents are raised, they would have this on a big screen, and they would be able to see that an alert's come up for their area, and it would be filtered for them. So on the shop floor on the right hand side, we've got this platform working on mobile devices. So the user will be able to see that at the shop floor. They'd raise their alert on their mobile device. They can also track the fact that that alert that they've raised has been acknowledged, that it's been resolved, and that it's being progressed. So all of this data is stored in a standard SQL database and can be used for reporting using standard analytics tools as well, such as Power BI, to supplement any further data analytics. So here's a more close-up look at these mobile screens. So we've got a supervisor view on the left. So it gives the ability to run through alerts, change their status to assigned or resolved. So a supervisor or team lead could look at these faults and assign them to particular team members to resolve. And then the operator view on the right has the ability to add notes and also raise the issues we've got down here. So we've got quality certificates, heavy lifting, risk assessments. So any information that's key to a particular machine, you could also use there. And they can see the alert that they've raised. They can see it being acknowledged and that someone's going to come and fix their problem.
Sorry to interrupt. We have a question regarding iPads. Does it work on iPads?
Yes. So these mobile devices, so it's all done on HTML5. So yeah, it'll work cross devices, mobile phones, iPads, tablets. Yeah, and it auto scales depending on the resolution that you need. So this has all been put
thanks.
together in a tool called Ignition, which is kind of one of the new disruptive SCADA systems. Yeah.
Okay, thank you.
So yeah, so final slide really. So how can ATS help? Well, we've been operating in this space for over 30 years. We've got a lot of experience connecting up shop floor machines, integrating them into meaningful and value-driven systems architecture. So this OEE project's been developed as a rapidly configurable, deployable system that can really bring you meaningful insight and value to your business, really. Yeah, so we put it together because there's a need out there that we're experiencing by going out and seeing people. Lots of people are focusing on OEE at the moment, and we've put this together as a way of helping people take that step quickly, really, and easily. And then also being developed on the Ignition platform gives you the ability to then integrate it into your other systems and start to move your digital strategy forward, really. So yeah, if you want to discuss this further, then please get in touch and we'd be happy to run through this in more detail or give a live demo of the system. And that's all from me, unless there's any more questions.
Mike, no more questions, so I think we can close the session. Thank you for your presentation.
Okay, thanks everyone.